When it comes to making your own custom gasket, choosing your material is an important task. With numerous options available, selecting the best material requires evaluating and testing based on your project needs. That's why in this video, we will cover the most common types of gaskets and materials so you know where to start your evaluation process. Gaskets are materials used to create a seal between two surfaces to prevent the leakage of substances like liquids, gases, or energy discharge. They are essential for maintaining proper sealing in various applications and can be designed for specific conditions, such as resisting heat, pressure, or electromagnetic interference. Finding the right gasket type depends on your application, substrates, and the intended length of use. So let's go over 5 common gaskets that you may use for your application. Starting with pipe gaskets. A circular gasket used in pipes requiring high compression tolerance and resistance to corrosion and extreme temperatures. Next is jacketed gaskets. Gaskets with a soft core covered by a metal jacket. Their layered construction provides a combination of flexibility and strength for harsh conditions. Third is spiral wound gaskets. They are made of metals, plastics, or rubber which are wound in layers. They're ideal for sealing high pressure and high temperature joints. Fourth is cam profile gaskets, made of corrugated metal cores covered with sealing material. Last is solid gaskets. They're made from metal and are cost effective and suitable for high pressure and high temperature situations. Each type of gasketing material will have slightly different properties, with some offering resilience against specific forces and others providing durability and flexibility for tight seals. In addition, some applications may present unique engineering challenges requiring custom gaskets. So let's take a look at the gasketing materials that we have seen work for different applications. First is gasketing tape and adhesive. Pressure-sensitive materials that reduce noise and seal gaps, often used in doors, windows, and threads. On the other hand, there is thread tape which fills gaps to create a tighter seal and reduces friction, preventing thread damage from vibrations or impact. Next is gasketing foam, a flexible material for irregular surfaces or noise reduction, commonly used in HVAC systems. It provides cushioning and thermal insulation in addition to its sealing properties. Fourth is silicone gasketing. These gaskets have a high elasticity and temperature tolerance ranging from -67°F to 400°F. It is commonly used in automotive and medical applications due to its flexibility. Next is neoprene gasketing, a durable rubber polymer with moderate temperature resistance ranging from -40°F to 230°F. They are resistant to oils and gases, which make it ideal for sealing in mechanical and outdoor environments. Sixth is EPDM gasketing, which uses a synthetic rubber to offer excellent weather and ozone resistance. Its electrical insulating properties make it suitable for appliances and industrial machinery. But EPDM doesn't do well with petroleum fluids or oils, which you need to keep in mind. Next is butyl gaskets, a rubber material resistant to weathering, ozone, and abrasion, with good electrical isolation and low permeability. Its airtight properties make it ideal for sealing in automotive and roofing applications. Next is nitrile gaskets. They are resistant to petroleum oils and gasoline, though limited in weather and UV resistance. It is frequently used with fuel systems and hydraulic applications. Next is SBR gaskets. Made of natural rubber alternatives, they have better water resistance. Its affordability and durability makes it popular in general purpose gaskets. Next is natural rubber. Its high tensile strength and water resistance. While it offers certain benefits, it generally doesn't age or degrade as well as polymers and synthetic rubbers. Next is Gore-Tex gaskets, which are a flexible, expanded PTFE with a high temperature resistance as well as strong against corrosion and solvents. Its superior flexibility and strength make it perfect for critical seals in medical and industrial devices. Next is Teflon gaskets, a corrosion-resistant and high-temperature material with a low coefficient of friction. It is widely used in chemical processing and food-grade applications for its non-reactive surface. Next is graphite gaskets. These non-porous material is very durable, heat-resistant, and has excellent compression characteristics. They are commonly used in high-temperature applications such as in furnaces and heat exchangers. Lastly, we have compressed asbestos-free gasketing, made from a synthetic material resistant to high heat, hydrocarbons, and inert gases. It is a safer, effective alternative for applications where asbestos was traditionally used. Choosing the right gasket material and ensuring precise tolerances are crucial for achieving optimal performance and cost effectiveness. Each gasket type has specific requirements, making proper selection and accurate measurements essential for a seamless seal. Testing materials and consulting with an experienced converter can help tailor solutions to your project needs. Beyond materials, a solid manufacturing plan is key, and a flexible material converter can guide you from design to production for the best results. If you want to learn more about gaskets or how working with a converter can help you in your process, visit our learning center for countless videos and articles, or feel free to reach out to us directly. Thanks for watching.